Hello, so in this video we will talk about the so-called Weibull distribution. So the PDF of the Weibull distribution is given by this expression where we have r over alpha x over alpha to the r minus 1, then the exponent of x over alpha negative to the r x over alpha to the r and negative sign outside. Okay, now note that if I put r is equal to 1 here, then this guy goes away and we have 1 over alpha here and we have exponent of e to the minus x over alpha. So this means we have exponential distribution here. Okay, so for r is equal to 1, this collapses to an exponential random variable. Okay, and r is always a positive variable, which is also known as a scale parameter, and alpha is also positive, which is known as the shape parameter. Okay, so now what we are going to do is we want to find the mean of this guy, and we want to find the variance of this guy. Okay, and the helping tool we will use is that we will use this definition of gamma function, because eventually what we will do is we will write the mean as some gamma function and we will write the variance as some gamma function. Okay, or some linear combinations of gamma functions. So what we want to do is we want to keep this in mind, and whatever integrals we encounter, we want to make use of this gamma definition here. Okay, so let's start with the definition of mean here. So what is our mean? Okay, so we have mu x, this is equal to 0 to infinity, and for the sake of completion, x is always positive here, so that's why we have 0 to infinity here. So x fx dx. Okay, so then this is equal to what? So I can say whatever does not have x, I will take outside right away. So we have r over alpha here, then we have 1 over alpha to the r minus 1 here, and then we have 0 to infinity, then we have this x, then we have this x to the r minus 1, then we have this exponential of minus x over alpha to the r dx. Okay, so then I can actually remove this and I can say x to the r. Correct? Okay, now I'm going to use a substitution. So we will actually say that t, this is equal to x over alpha to the r. So this means what? We can say t to the 1 over r, this is equal to x over alpha. Correct? And then we can say x, this is equal to alpha times t to the 1 over r. And if the limits of x are from 0 to infinity, the limits of t are also from 0 to infinity. Why? Because if I put x is equal to 0, this guy becomes 0. When I put x is equal to infinity, this guy becomes infinity. So that's why we have the same limits for t and x. Okay. Now what is dx? So dx, this is equal to alpha times 1 over r t 1 over r minus 1 dt. Correct? It's basic differentiation here. Okay, so now coming back to our mu x, so mu x becomes r over alpha 1 over alpha r minus 1. Now x to the r, right? So x is what? This. So this is alpha to the r t 1 over r and r, so t to the 1. Correct? Then we have exponent of minus t to the r, then we have dx, and we have alpha here, then 1 over r here, then t 1 over r minus 1, and then dt. Okay, now it's a matter of just combining terms here. So we have r here and we have r here, so this goes and this goes. So we have alpha r minus 1, they become alpha to the r. So alpha to the r, this and this. Then we have alpha outside, so we can say alpha, and of course we have 0 to infinity here. So 0 to infinity. So t here, t 1 over r minus 1 here. So this becomes t 1 over r, and then this is e to the, so this is wrong, right? So this is just minus t, because this whole thing is my t here. Okay, so this is e to the minus t dt. Now compare this with this guy. Now we have e to the minus t here. This is just a dummy variable, so we can compare. And this is a minus 1 here. So, and this is 1 over r here. So this means that this I can say alpha gamma of 1 plus 1 over r. That's it. So note that this guy is 1 less than this guy. Sorry, this guy is 1 less than this guy. So this guy is 1 less than this guy here. And this alpha is just this alpha. Okay, so this is my mean here. Okay. Now let's come to the variance. So variance is exactly the same thing. We'll use exactly the same distribution, but first of all we will calculate the second moment, which is 0 to infinity x squared. Same procedure as you will see. So this is equal to, again, r over alpha 1 over alpha r minus 1. So x squared here, x to the r minus 1 here, and then exponential of the same story, and then we have dx. Okay, so now this guy is equal to, and this is 0 to infinity, r over alpha 1 over alpha r minus 1, 0 to infinity x to the r plus 1 exponent of minus x over alpha r dx. Okay, now again we use exactly the same substitution. So we say t is equal to x over alpha. So then this means that x is equal to alpha times t 1 over r. So this means that dx is equal to alpha 1 over r t 1 over r minus 1 dt, and then limits of t are also 0 to infinity. Okay, so now we go e to the x squared. This is equal to r over alpha 1 over alpha r minus 1, 0 to infinity. So this is x to the r plus 1. So then I can say alpha r plus 1 and t r plus 1 over r, correct? Because r plus 1 here and 1 over r here, so they multiply and I will get this guy. Then exponent of minus t. Now dx is what? Now we have alpha 1 over r t 1 over r minus 1. Then we have dt. Okay, so what can we take out? So first of all, this r goes with this r, this alpha goes with this alpha, this alpha r minus 1 and this alpha r plus 1 will give me alpha squared. Okay, and then this is r plus 1 over r, this is 1 over r minus 1. So let's do it here, r plus 1 over r plus 1 over r minus 1, correct? So this is r plus 1 over, so what we can do is we can say r plus 1 minus r, because this one is r over r. This goes, so I have 2 over r. So this leaves me with 2 over r here. Okay, now again this is we have alpha squared 0 to infinity t to the 2 over r e to the minus t dt. So again using the gamma function definition, so we want one more than this, correct? So alpha squared gamma of 1 plus 2 over r. Okay, so this is the second moment. So what is the variance? So variance This is equal to the second moment minus the mean squared. So mean is, we already have shown that this is the mean. Okay. If you want, you can take alpha squared out. If you, I mean, but that is just a simple simplification. So this is the variance of the Weibull distribution, and the mean was calculated to be this expression. So this, there was nothing much, much tricks to it, except that we used that gamma function is well defined. I mean, there are tables available, and you can find the value of gamma function for almost any real number. Okay, so the point is that we have to use this definition of gamma function and translate whatever integrals we encounter into the definition of gamma function, and this way we can represent our mean and variance for for a Weibull distribution in terms of this gamma function. So this is it about this video, and hope it was clear enough to understand. Thanks for watching and hope you like the video.